How's it going, Math 1 people? This is lesson 5.2, Domain and Range of Functions. In Khan Academy, for the Math 1 class, we are in Unit 8, which is titled Functions. And after this lesson, you should be able to complete skills 8, 9, 10, 12, and 13 in Khan Academy. All right, our objective is that you'll be able to identify the domain and range of a function from a graph and from algebraic limitations of a function. So let's get right into it. We have some definitions here. The domain of a function is all the inputs, all the x values of that function, and the range is all the y values, or all the outputs. So if you are finding domain and range from a graph, we're trying to pick out all the inputs, all the x values for domain, and then all the outputs, or all the y values for the range. So we have a graph here. Notice there's just an endpoint. It doesn't have like an arrow. So the function starts here, and we've got a bunch of different outputs, so it doesn't have to be linear like before, but that's our whole function. And so we're trying to explain what are all the different x values from there to there, and what are all the different y values. Well, it looks like the lowest one's down here, the highest one's kind of up here, and we'll list that out on the side right now. So I'm going to draw the domain in blue. We just write a capital D for a domain, and we list it out. When you want to find the domain, I want you to think left to right, because we're talking about x values, and the x-axis runs from left to right. So the leftmost point on our graph is right here, and the rightmost point on our graph is that one there, right? So I remember earlier I traced the entire graph with my green pointer, and it's continuous. I didn't have to pick up my pen to do that. So everywhere in here, every x value in here is part of our domain. We can say that the smallest that x could be is -6, the biggest it could be is 7, and we're just going to write a compound inequality to show that x can be anything in between. X could be -5.9 if we wanted, x could be 6.99999, or it could even be 7 because we have this or equal to line. It could be anything. It could be 0, 1, 2, any number in between. All right, let's talk about the range. So for the range, we just draw a capital R, and I want you to think up and down, because we're looking at the y values now, and the y-axis runs vertically. It runs up and down. So the highest point on our graph is right here. It's kind of tied because it's flat right here, but there's no y-coordinate greater than 8 on this graph, and there's no y-coordinate less than 3 on this graph. So anywhere in here is part of the range of the function. So we can write that out as, instead of y, I'm going to put f of x, and the smallest y value we had, I already said, was 3, and the biggest one was 8. And so that would be our range. Okay, let's go ahead and try example number 1 in the same way. So our domain, thinking left to right, there's our leftmost point on the graph and our rightmost point on the graph, and it's continuous. So anything in there is part of our domain. We could say that -7 is less than or equal to x, which is less than or equal to the right side, which is 7. All right, and then thinking up and down, the highest point on the graph is right here. The lowest point on the graph is right here. And anything in between is part of our range. So negative 9 is going to be less than or equal to f of x, or y values, which is less than or equal to 9. Okay, I want you to try practice problem number 1 on your own. Go ahead and pause the video, find the domain and range, and then come back to check your work. There we go. So our domain, the x values are between negative 9 and 7, and our y values, or our outputs, our f of x values, are between negative 6 and 4. You might not be given a graph. You might be given an equation or a function like this. And there's 2 rules that you need to know. In fact, sorry, go ahead and fix these typos. Sorry about that. But sometimes you'll be asked to identify the domain of a function without a graph or a table, just with the function itself. There's 2 rules you need to know that you've probably already seen before but may have forgotten. So with square roots, you will not be able to take the square root of a negative number, but you can take the square root of a positive number and 0. So when you first learn square roots, let's just do a quick reminder. Why is this the case? Why can I not take the square root of a negative number? That square root symbol, you should be asking yourself, what number times itself makes whatever number's inside. So like, let's say I asked you, what's the square root of 25? Or what number times itself makes 25? Can you think of one? Hopefully you thought of 5. 5 times 5, 5 times itself is definitely 25. Can you think of another number? Any other number that when you multiply that number by itself, you get 25? There actually is another number. It's negative 5. Because if I take negative 5 and I multiply it by itself, negative 5 times negative 5, remember that a negative times a negative is a positive, it would also be 25. What if I asked you the other thing, though? What if I said, what's the square root of negative 25? Or what number times itself gives you negative 25? Well, it's not 5, because 5 times itself is going to be a positive number. It's not negative 5 either, because negative 5 times itself is going to be a positive number. In fact, there is no real number, that says there, sorry. There is no real number that when squared, or when multiplied by itself, makes a negative. Because of that, that's why we have this rule. You'll actually learn in Math 2 how to take square roots of negative numbers, and you learn a new set of numbers called imaginary numbers, but that's beyond the scope of this course. For now, we're just dealing with real numbers, and all you need to know is that there's no real number that squares to make a negative, so we can't take the square root of a negative number. But what does that mean for domain? Since we can't take the square root of a negative, and I see this function here, it's not linear, but that's okay. I see a square root symbol. I know I can't take the square root of a negative number, so that stuff that I circled here, this can't be negative. Otherwise, I'd be taking the square root of a negative number, right? So, using symbols, that 3x plus 5, if it can't be negative, that means, well, it could be 0. I could compare it to 0 and say it could equal 0, but I could also say it could be greater than 0. In other words, it's either positive or equal to 0, but not negative, right? And this should look familiar. We did this in chapter 4 last semester. We've solved lots of these inequalities. Technically, This is one way to state the domain, but you will be required in this class to get x by itself. So please solve this inequality, get x by itself, and state your domain that way. We can take 5 from both sides. We'll get 3x is greater than or equal to negative 5. And I can divide both sides by 3. 3x divided by 3. Negative 5 divided by 3. I'm dividing by a positive number, right? So the inequality stays the same. And I'm left with, this is the negative 5 from before. But I'm left with x is greater than or equal to, just leave the fraction, it's negative 5/3. And we'll put that in our domain. X is greater than or equal to negative 5/3. All right. Let's try another example here. We can't take the square root of a negative, so if g of x is the square root of the square root of 9 minus 2x, and then that square root plus 8, we still know that the stuff inside the square root symbol, that's actually called the radicand, it can't be negative. So 9 minus 2x has to be greater than or equal to 0. I could take 9 from both sides. I'd get negative 2x is greater than or equal to negative 9. And then I can divide both sides by negative 2 to get x by itself. But remember from chapter 4, we're dividing both sides of an inequality by a negative number. So the inequality has to change directions. This less than symbol, less than or equal to, changes, the greater than or equal to symbol has to switch to a less than or equal to symbol. So we'd be left with x is less than or equal to negative 9 divided by negative 2. A negative divided by a negative is a positive. So I can just write it as 9/2, or 4.5, or 4.5, whatever you want to write. But that would be our domain. X is less than or equal to 9/2. Go ahead and try practice problem number 3 on your own. Remember that the radicand cannot be negative, and then come back and check your work. All right, so there's our work. We set that stuff inside the square root sign, the radicand, it can be greater than or equal to 0, and we end up with x is less than or equal to 13/6. All right, so that was the first rule that you need to know for domain. We cannot take the square root of a negative. The second rule that you should know is that we cannot divide by 0. That is a big no-no in math. Don't divide by 0, but you can divide by a positive or a negative number. And again, the why part of that is, think back to when you were first learning division, and maybe you had some word problems like little Johnny has, 20 candy bars, and he wants to share them fairly among 5 people, right? So he's got 20 candy bars. You probably wrote division this way at first. And if he's sharing them among 5 people, well, the fair thing to do would be that each person gets 4 candy bars then, right? You're allowed to divide 0 by a number though, right? I could say, well, man, Johnny didn't bring any candy bars today. He's got 0 candy bars, wants to share it evenly, fairly among 5 people. Well, that's still allowed. It's just everybody gets nothing, right? Everybody gets 0 candy bars. The problem happens when you have a certain number of candy bars, say 20, and you want to share it evenly among no people at all. If that's the case, I've got 20 candy bars and I want to split them up among 0 people, it doesn't really make sense to ask how many candy bars does each person get, because there are no people. This is undefined. We talked about this last semester when we were dealing with slope, and we had a vertical line that, the slope had a rise, but the run was 0. We can't divide by 0. So in terms of domain now, If we have a function with division in it, like h of t is 1 divided by t, we can't divide by 0, so that cannot be 0. The way we write that is just t does not equal 0. In fact, that's all we have to do. There's no more work to be shown. T cannot be 0. It can be anything else, and so this means t could be a negative number, t could be a positive number, it just cannot be 0. That example was, I think, a little too easy. So let's do practice problem number 4 together. Again, we're dividing. F of t is 1 minus 5t all divided by t minus 2. So again, this can't be 0. So we'll say t minus 2 does not equal 0. Well, if t minus 2 does not equal 0, that's the same as saying t cannot be 2. There we go. That's our domain. T can be anything else. It just can't be 2. Since those ones were a little bit more simple than you'll see in Khan Academy, I made one more practice problem for you. Please write this down in your notebook, and this will be the last one for our notes. So we have a function here, f of x. Remember that you cannot divide by 0. I want you to try this one on your own and tell me what the domain is. Remember to get x by itself. Pause the video and then come back and check your work. There we go. So all that stuff in the denominator can't be 0. If we add 10 to both sides, that means that 2x cannot be 10. And if we divide both sides by 2, that means x cannot be 5. And that is our domain. X can be anything else, it just cannot be 5. It could be negative, it could be 0. X could be 1 or 2 or 3 or 4 or 4.5. X could be 5.1 or anything bigger than 5, but it just cannot be 5. All right, that is the end of our notes for 5.2. As always, please type any questions you have at the end of this video, or if you don't have any questions, then make up your own practice problem, and I will see you all in class.